Isaac, and in this video we will present my work for session 17 on fuzzy logic using MATLAB. So now let's take a deeper look into MATLAB or our following example. First of all, we're going to see the overall graphical representation of the fuzzy expert system. Here, as you can see on the left, we have the three inputs: food, atmosphere, and service. In the middle, we know we'll have the name, and we also know what we know as the fuzzy reasoning block. Here is where the inputs go into fuzzy sets, the rules are applied, and we're also going to see the reasoning behind our work. And on the right, we have the output, or what we name as tip. Now let's take a more closely look at the definition of each variable with their membership function. First of all, we have food that ranges from 0 to 10 with three triangular functions: bad, average, and good. Each going from 0 to 10, which this means that food can be completely bad, completely good, or partial between the two states. We also have the same in atmosphere that goes from 0 to 10, bad, average, and good. And we also have the same in service that goes from bad, average, and good from 0 to 10. Each of these inputs is modeled with overlapping triangular member functions. This overlap is important because it allows the system to handle values that are not purely one category. For example, a food score of 6 may be considered partially average and partially good. Now we'll take a look into the output, or what we know as tip. As also mentioned before, we have the range from 0 to 25. We define the three membership functions: low, medium, and high, which each with their own parameters: 15, 25, 25, medium 5, 15, 20, and low 0, 0, 10. These also overlap, so the system can suggest a tip that is not strictly one category, but a weighted combination depending on the situation. This graphical representation of the membership function shows how each variable is broken down into linguistic categories that the fuzzy system can use. Now let's take a deeper look into the queries and test our function. Here we have the query number 1 with food equals to 2, atmosphere is equal to 4, and the service equal to 2. The system returned a tip of about 3.6, which is clearly low because this makes sense because both food and service are poor. Query number 2, we have that food is equal to 5, atmosphere is equal to 8, and service is equal to 6. The result was about 14.5, which corresponds to a medium tip. Here some inputs are average and some are good, so the system suggests a fair middle ground. Then we have the last query, that is query number 3. Here all are 10s, which means that the result was about 21.7, which represents a high tip. This shows that when all the inputs are excellent, the tip is near the maximum. These queries demonstrate that the system follows the rules and produces outputs that match human intuition. In conclusion, fuzzy logic is a powerful tool for decision making when information is uncertain or imprecise. Instead of only yes or no, it lets us reason with degrees of truth similar to human thinking. In my opinion, fuzzy logic can be very useful in my professional area. For example, in data analysis and IT system, fuzzy logic will help evaluate service quality, customer satisfaction, or system performance where the data is not always exact. These exercises help me understand how fuzzy logic models human reasoning and how we can implement it in MATLAB to build expert systems. I really hope you like this video, and I'll see you next time.